All right, so guys, let's do this. So again, if you have your work perfect, just check that with mine, and also go ahead and finish it up. When I get to the part that you haven't finished. All right. Now, if your triangle looks slightly different, just because you go with A, B, C, it doesn't matter, right? But you have to make sure that you label the correct corresponding angles and the sides, right? That's a lowercase c, right? Has to be the opposite of the angle C. So we know two sides, right, and an angle. So now what we're looking at, now please make sure that you write down the law of sine, pretending that it's a test question, because you're going to get, seriously, you're going to get a point just for writing it down. It's going to be the same every time, right? A over sine A, B over sine B, C over sine C. If you don't have it in your work, leave a comment right there, say that, putting the law of sine, okay? So now what do we have? We have the angle A, 35 degree. We have little a there, right? What else? Little b, right? So I'm sure that I don't have to ask you to solve for anything. You see that the letter B should be ready to go, right? So we'll take the first equality to cross multiplication. So little a times sine B, right? So it'll be 12 times sine B is, letter B is 16, right? 16 times sine A, which is 35 degree, right? So finding the sine B just by isolating the entire thing, right? That will be 16 over 12 times sine 35. Oops. Did anybody have the value for sine B? Not the B, but sine B. Okay, let's go with 0.76. Now, this morning I've been grading a test paper, and I noticed something that's kind of concerning. So let's say people are getting sine B, which is 0.76. Okay, so if I wanted to find the B, the angle B, what would you do? Inverse, right? But what if I see something like this, 0.76 divided by sine? What is that? Those three letters are not numbers. They're the name of the function, right? You cannot do that. But I've seen a lot of students in the last problem on the test, they divide out whatever's in front of the variable. I guess because you're so used to doing that. This is a function, right? So you wish that will work out. And I guess in calculus, you've probably been taught that way. And turns out that you need to listen to the full story. We don't have a reciprocal for the function name. Okay, we do have the reciprocal function, which is called the cosecant, right? But in this case, you need to find out what the angle B is by using the inverse sine 0.67, right? Donovan, how much do you get for letter the angle B? Okay, good, that's fine. So let's say 50 degree. Now, could there be another possibility for the angle B? How would you find the other angle for B? Remember that sine, Jordan? Or supplementary angle. Supplementary, yes. The supplementary angle of 50. You guys all see that? So I don't have to explain why, right? There are two possibilities for the sine, thinking about unit circle, you have an angle in the first quadrant and second quadrant. So that will be 130, right? It's 180. If you're thinking about how I got 130, it's 180 minus 50. So it's a complementary angle. Or if you want, you can call it reference angle. Same in this case. But getting two possibilities doesn't mean that you're going to keep them both. Okay? In this case, you do. But you know that in the test, they're going to trick you. to see if you're going to keep both, right, or throw both away. How do you know you're going to keep both or one of them? It turns out it is as simple as you find out the third angle, since you're going to do that anyway, right? So let's say what will be the angle C? So let's say case number 1, right? So if B is 50, right? A is 35, of course, right? So C has to be 180 minus 55 minus 50 minus 35. Come on, right? So I believe this is 95, right? Is that a angle that you can have in a triangle? Yes, right? So they added to 180. Nothing wrong with it, right? So now you have all 3 angles, right? In this case, what are we looking for? The last thing, the little c, right? So what you can do, just, I mean, however you want, maybe take the second inequality, not inequality, equality there, right? Say, look, I have b over sine b equals c over sine c, right? And go ahead and do cross multiplication, and however you do it, get what the c is, right? So I'm not gonna embarrass you with, you know, the trivial work, right? I'm sure that you all get it, but make sure you get it done at least once. All right, so get that C, you're done for the first case, right? The side C. Now the second case is, hey, what if B is 130? A is still 35. So now you're looking at the angle C, which is still coming from 180, subtracting now 130 and 35. So you're left with 15 degree. Am I right? Again, you know, ask yourself, it's okay to have 15 degree for angle C? Of course, right? Nothing wrong with it. You do the same thing to get that little c. And I believe that both cases works out, right? And therefore, if I zoom all the way out, you'll see that on the very top, they call this problem the one with 2 solutions. For you to take pictures if you want. Is it okay?
Like an often occurrence?
I would say more than often, you know, because think about if I'm not supposed to say that, but you know, in general, instructors tend to design questions that are tricky, right? So then, you know, it will be good for them to check those kind of ambiguities and have you to even work on both cases, right? All right. Now, before I move on, yeah, go ahead, Rebecca. Say it again. Good question. So Rebecca says that, are we going to find 2 solutions? Or how do we know we need to have 2 solutions, right? Or do we have to find them both? It all depends. So, and that's the part, you know, of the question and the things that they're checking. So you have to be the one to determine if there'll be no solution, like you saw maybe the other day, right? Or one solution that's most likely what you're expecting, or in this case, 2 solutions, okay? But I'll try to be reasonable. If there are 2 solutions and you figured out one of them, I'll take 1 or 2 points off. Usually, you know, like 1 or 2 points off out of 5. Right. Yes. Okay.
Like what's not going to work?
Let me ask you why we're checking the second possibility. First off, do you realize that not just 50, 130 is going to work out for the letter B, right, for the angle B. So that means you're thinking, if I know the angle B, should you find the angle C, since you're going to have to do it, right?
Yeah,
how would you find the C? You just subtract, you know, those 2 angles, B and A, from, you know, 180, you get that, right? Now, the reason why we are keeping the second possibility is it still works out as a fine angle, right? But what if somehow, you know, the math works out and a B is 20 degree. What's the other possibility? If it's 20, 160, right? Okay, so if you take 20, 35, subtract them out from 180, you're going to get a fine angle for sure, right? What if you do that with B to be 160? A is still 35. It will be less than 0. And you know that's not going to work. So you keep one of them, right? Yes, it's as simple as you do what you got to do, and the math's going to tell you somewhere along the way that you shouldn't keep that solution. Yes. If the numbers you're getting for C are an angle, which might not be an angle, is what if you get negative 20? Okay, so all right, so what I'm saying is given A to be 35, okay, given A and a B to be some numbers, right? So somehow, by doing the same thing, I figured that B is sine inverse of something, and it works out from a calculator, which is 20 degrees. Rebecca, I'm just assuming, right? So, right, so you know how to work out the angle B, right? If it turned out to be 20, do you know how to find the other possibility for angle B? Rebecca, what do you think will be the other angle? B could be also, it's one minus, right, so 180 minus 20, so it'll be 160, right? So at this point, you think, okay, should I go with both routes? Right, case one. So C, because you're gonna find the third angle, right? So angle C will be 180 minus A, which is 35, right? B is now 20, right? So what you get is 125, right? I mean, does it seem a good angle for you to you? 125 should be fine, right? Okay, let's keep it. All right, case two. You do the same thing, right? But instead of subtracting 35 and a 20 from 180, you subtract 35, which is still the angle A, right? That's what they told you. But now this time the B could be 160. So now let's see a problem. You got what, negative 5 degree? Not negative 15 degree. Am I right? 195, yeah, negative 15. Does it look like a correct angle? No, right? And then, before this section, you say, what's wrong with negative 15? It's an angle, right? But you don't have that kind of angle in real world, right? Can you imagine a triangle that has negative 15 as an angle? So it's, I don't know, like, it should be obvious enough, but if you haven't seriously thinking about, you know, the real world situation, you didn't realize how obvious it is. It tells you that the second case does not even exist. Forget it, okay? Now, well, since, you know, that's actually a very good question. I think that, to me, this is probably the most important thing in this section. I don't have to check anything because, you know, it will be embarrassing to check, you know, do you know how to do the cross multiplication? Do you know how to put in things in a calculator? But I want to see that if you're able to do reasoning like that. So now, is it possible that as you're doing the inverse sine, right, which you put in, let's say, inverse sine of 1.5, somehow it worked out, right? So putting inverse sine of 1.5, your calculator is going to complain. Says that it's an error, right? So that means you were stopped by the calculator at such an early stage when you try to find the angle. You did everything right, but the calculator says this doesn't work. What does it tell you? There's no solution at all because you couldn't even find out an angle. And I think that showed you the graph, right? Why there couldn't be an angle, there couldn't be a triangle, right? So that's why try the quiz problem, and you will see maybe some of the homework problems. There will be problems that you literally type in something that's greater than 1 into the inverse sign. Again, if you remember that back in chapter 6, chapter 5, right? The restrict domain of sign is from 1 to 1. Sorry, not the restrict domain of the inverse sign is 1 to 1, right? So you cannot have anything greater than 1 into the sign function. All right. Anyway, so much for this. Moving on. And since that, we need to introduce you a new formula for the area of a triangle. So I'm sure that everyone knows the area of a triangle is 1/2 times the base times the height. And it is still the same, but written in a fancy form. Okay. And that's why you see that here for any kind of triangle, right? But let's not do a obtuse triangle, because if it works out, it works out. With those kind of acute angle triangle, it's kind of nice to see the height right there, right? So let's say, how do I find the area of this triangle? You take the base, which is little c, right, times the height, you know what the height is, times that magical factor 1/2. But how would you find the height if you're given little a, okay, and the angle b? So my question to you is, if I tell you what the little a is, let's say 10, angle b is say 50 degrees. How would you find the h? Do you guys see the right triangle right there, right? This is the right angle, which means A is the hypotenuse. Knowing the angle B, which you're looking for, the height is the opposite of angle B. You should use the sine function, right, to find out what the height is. So let's do that, right? So given that, given little a and the angle B, right, find h. Well, it's as easy as a times sine b, right? Does it work? Sine b is opposite over hypotenuse. We're solving for the opposite. Therefore, it's the hypotenuse times the sine b. And what about the area? Let's find the area. Oh, you know what? Given the c, right? The area will be 1/2 times the base, which is little c, right? Times the height, which is a, times sine b. And that is that last formula right there. You see that? 1/2 times AC sine b. Okay, so you can prove the two remaining, I just randomly picked that one. All right, you can prove the two remaining formulas, not two remaining formulas, two remaining forms of the same formula by asking yourself, what if I know letter B, how will I find the height if I know the angle A and a B, right? You still have the same, base, which is C. Or what if you draw another height on the side AB, side BC, right? Do the same thing. All right. If you ask me, what's the point of that? Have you ever seen problems that ask you for the angle, the triangular area? They don't provide you the height. They know if you know the height, it's pretty much problem solved. So they will make it a bit harder by not telling you the height. But now I want you to see the beauty of this equation, this formula. You don't need to know the height. all you need is two sides and the angle in between. Not the angle somewhere else. It's the angle in between the two given sides. Check that. BC, angle A. Is the angle A angle in between B and C? Take a look. B, C, angle is in between, right? Take a look at this. AB, sine angle C. C is right on the top, right? The sides are A and a B. The angle C is in between. The last one, side A and a C, and the angle B is in between. And you always have that magical factor 1/2. Okay. That's all. But I typically remember this formula. I mean, there's no point of actually, thinking about a fancy way to do it, I go with 1/2. You know what? I'll just let you know that if I get to choose which form I like the most, since they're all the same, right? I'll pick this one. The reason is they're in an alphabetical order. AB, sine C. Okay? That way, if you just draw a triangle, right, label the sides, write this down, it doesn't matter that they told you little c instead of a little b, right? Because you know that, you just call them whatever you want, right? You need that formula written down so you can look at it. Okay. Since we're looking at this triangle, one of my second period students keep asking me, to show her how to prove the law of sine, law of cosine. And I said, wait for next week. So now that's the perfect moment. And you will see that it's as easy as referring to this triangle. When it comes to law of sine, it takes you less than a minute. So that means, you could remember if you want, right? Law of cosine, it takes maybe 2 or 3 minutes. And that's it, right? So let's do that real quick. At least that, you'll see that these equations are, first off, very powerful, and also they are really some natural consequence of having the fundamentals of triangles that you know very well. Okay? Let's prove the law of sine. Okay. Let's say in the triangle CDB. Okay, so take a look at the vertices. CDB. That's a right triangle, right? How do I compute the height h? Using the sine function. So I'll write down something that you tell me if it makes sense. It will be A times sine B, right? Am I right? In a triangle CDB, the relation between, or the relation among the opposite, right, which is the height of the triangle, the hypotenuse, which is little a, and a corresponding angle B, right? That's basically the definition of a sine. Okay, what about in a triangle CDA? Can I do the same thing to find out what the h is in terms of little b and angle A? I'll write it down. B times sine A. Am I right? Now I'm looking at the small right triangle on the left. Now, what can we learn from these two equations? It's the same h, right? That means A times sine B must be B times sine A, right? Is that something that you were expecting based on the law of sine? Can I write that equation in such a form that looks like ratios are equal? Now, how about we divide both sides by sine B times sine A. Divide out both of them. Sine A get canceled on the right, sine B canceled on the left, right? Therefore, you arrive at A over sine A, B over sine B. That's it. If you say, well, what do I do to prove that B over sine B is the same as C over sine C? I mean, you can literally just recall or say, you know what they do usually in the textbook. Similarly, you prove the rest, right? I mean, they didn't lie because it is really the same thing. You just do it again, right? The same logic, right? Or, you know, if you want to sound a bit condescending, if you want to do that, you say, obviously, right? It works out just to show off how much you know about math, right? Trust me, it's not, them trying to, make them those textbooks, because they literally say that. And I still remember one of my a quote from my teacher back in graduate school. So we use a textbook which is only this thick for a whole year of our graduate, physics course, okay. And you can easily find one single equation in that book that takes pages of work to show why it is right. And the guy will say, obviously. The guy knows the answer. They're lazy. They don't want to type up, everything because, you have to type a latex, to, write these equations. It's not me that's just writing. They never take these as a publication, right? Just write the handwritten things. No. And so, you're, when you get to college, you're spending only 2 years, right? Get your undergrad degree. I was joking with another instructor, last time. They will care about the format of your dissertation way much more than what you're really writing. No one's going to look at it. But they will catch, you didn't put a comma there. It's not in the right font, not the right size, right? I want bullet points in this kind of style, right? And they have my dissertation, even the template is 50 pages. You need to squeeze everything you have into the dissertation. You know what? I do the theory work, right? So my advisor is poor. He doesn't have money to support me so that I don't have to teach the undergrads. He's going to have some money to support the graduate student, but only for the last semester. The reason why I have to have that semester, so I don't have to teach the undergrads, is I need to type up my dissertation. So I don't do anything just by staying there, just type up, right? Copy and paste. Seriously, that's exactly what I do. But that's my work, right? It's not copy and paste from the internet. But you hit the button, say compile, right? Because I have everything, pages, my dissertation is like 100 pages. When I type up, I don't type up 100 pages and then check, right? Because that's almost impossible to debug. I type up a page, right? When I hit that button, you know what they say? That's the moment of the truth, right? Let's see if it works. There'll be errors. It's like the computer doesn't recognize the symbol, right? Doesn't recognize because I didn't type up, the correct command. Anyway, well, you know what? I just wanted to see, I didn't lie. So I don't know if they will ask you guys to do something like that. Okay, let's see. I have it here. Trying codes. Okay, sites. That's a template. The template I use to write, the articles. Right, so, oh yeah, citation. Oh yeah, so that's also something they're going to be crazy about. If you don't cite other people's work, then what you say is nonsense. And so let me show you another one that has more formulas in it. So I have to type it up, but now I don't have to because AI is going to do that perfectly. But only 10 years ago, I graduated in 2016. Yeah, 10 years ago. So let's see. I literally type out every single word in it. So do you see that? Those things, right? So let me compile it to show you know what it looks like once I'm done. So that's the moment of truth. I hit that button. If it shows me a whole bunch of red fonts, errors and warnings, screwed. And you know I have to go back and check. So let's see what it looks like. So
You know how to do this?
yeah. So don't worry about the math. I'm just saying that. Do you see that? You couldn't even write those things. You know, I couldn't even write it, but I did type it up exactly the way it works. Make sure it works out. You know, you're gonna have to number those equations, right? You're gonna make sure that those font looks right. And different publishers, say journals, right? They have their own templates. Some physics. Yeah, it's hard to explain. Anyway, yeah, but that's the reality, right? I'm not done. I'm still in school, still doing those kind of things. But at least I'm not doing physics anymore. I wish I could still do that, but it's just not. There's no money. There's no money for physics. Honestly, everywhere. Yeah, yeah. I'm not born here. That's gonna be a problem. You know, my dream is to work for FBI. But I couldn't. I couldn't. They even give Obama the hard time about his birth certificate, right? No, no, I don't think so. I don't think so. My son could be the next president. You know, he's born here. Anyway, I'm joking. I'm saying that. Anyway, now, well, let's see. What about law of cosine? Right. Yes, that's why you know I'll introduce you the law of cosine, not just by throwing that equation at you, right? So, yes, for FBI, but I guess not CIA.
Nobody's getting it.
CIA is, spies and really, you know, they maybe change the rule. Okay, sounds pretty promising. Maybe you'll see me, in my late 60s, slowly walk into the office, right? You know, the cool thing is, you know, you wear that jacket says FBI, right? Yeah, that'd be cool. And I saw those YouTube videos. Sometimes a secret agent, right, FBI, gets stopped by the cop, right, and the cops doing that kind of things, right? Hey, show me ID, right? So do all of that. I didn't break my law, right? So why would you? And they will say something to scare people. At the end, it didn't end well for the cop because he ended up being arresting the special agent, and happened to be on duty. So anyway, now let me call that segment BD, this one, the lowercase d, okay, and the segment AD, lowercase e. Okay, so my question is, instead of finding the height, let me find the little d. So still in the triangle CDB, little d is, you tell me if it's right. It's little a times cosine b. Am I right? I'm looking at this right triangle on the right, looking for the adjacent side of angle b. That works out as the hypotenuse times the cosine b. Okay, I'll put it here. Now, what about e in terms of little d and little c? Isn't that obvious that it's C minus D, right? I'm looking for that little part. You subtract D from the whole thing, you get little C. Okay? And also, please recall what we did for the H. You guys remember how I find the H in terms of A and a B? It's little a times sine B, right? You guys with me? Okay. Now, let's prove the law of cosine in the triangle CDA, right? By recalling the Pythagorean theorem. CDA, the two shoulder legs, right? H and E, right? H squared plus E squared equals B squared. Is that right? The two perpendicular sides, right? Sum of the square is the hypotenuse. What is H? H is A times sine B, right? Go ahead and plug it in. A times sine B square. What is E? E is C minus D. But what is D? D is A times cosine B square. Okay? And the B is still there. So if I say that this is, hey, guess what? This is the law of cosine. It doesn't look like it, but you still have to expand it, simplify it, right? And it turns out that our students can do that. If I ask you to do it, you can justify every single step, right? But what makes you guys different from a mathematician? You stopped, right? So if you do one more step, that will be named after you, right? Lot of Donovan, right? Lot of Rebecca. Well, I better go with your last name, but right? And guess what will be the last step? What will be the next step? Not the last step. What will be the next step you feel like doing after so much tedious, meaningless identities, right? What would you do? Square them out, right? This expand it. All right, so now see that you're multiplying A and sine B, right? It will be A squared times sine squared B. Don't freak out, it will magically, disappear. Do you guys know how to expand the difference of two terms up to the second power? The perfect square trinomial, right? It will be the first term, c squared, right? The middle term will be negative, right? This guy times that guy with a factor of 2. C times A times cosine B will be the last term. It will be this whole thing square, right? Let's write it as A squared cosine square B. So now, I guess you guys can still do that, right? But again, what makes it different from a mathematician? You keep an eye on things you could simplify. You guys see that? Put those two terms together, what do you get? Right? Those two terms add up to be A squared factored out, sine squared B plus cosine squared B, right? Oops. Now you still have the remaining, right? It's C minus 2AC, right? Cosine B equals B squared, right? This guy is gone as 1. Now guess what? You have A squared plus C squared minus 2AC cosine B equals B squared. Now, there are a lot of ways of writing the law of cosine. If you want, you can do this guy to the right-hand side, moving the B squared to the left-hand side. A squared plus C squared minus B squared is positive 2AC cosine B. Right? That's it.